to another episode of the Active House USA podcast. I'm your host for today, Saul. I am the marketing coordinator here at Active House USA. In today's episode, we'll be talking about hydronic radiant floors. Now, if you don't know exactly what that means, no worries. You should know everything you need to by the end of this conversation. We have two industry experts joining us today. First, we have David Knight, who is one of the co-founders of Active House USA. He is also the president of Monterey Energy Group. David, how you doing?
Great. Thanks for having me, Saul.
Of course. Thanks for being here. And then next, we have Morgan Muir of WBI, a radiant panel manufacturer. So we have someone on the engineering side. We also have someone on the manufacturer side. Morgan, how you doing?
Pretty damn good.
Awesome. Now, before we jump into this whole radiant floor hydronic conversation, David, would you mind just reminding our audience, what Active House is all about?
Sure. Active House is a green building certification and evaluation program. More than that, it's a building philosophy. And it's a building philosophy that looks very hard at true human comfort, as well as high levels of efficiency and solar contribution, as well as sustainable building. It's a very, very practical, low-cost, logical building certification program. It's been around in Europe for about 10 years. It's a bit of an offshoot of Passive House, a lot more design freedom, and again, a real focus on human comfort. One of the reasons we're here today with radiant floor heating is because radiant floor heating touches on that in a very strong way, and we'll get to that in a second.
Yeah, we will. Awesome. Great to hear. Good to know about Active House. And now, Morgan, you're with WBI. Do you want to give us a little background on what you guys do over there?
Sure. For the last 23 years, we've been making radiant panels that are lightweight, low-mass products for applying radiant floor heat to raised floors, and now products for going over concrete, doing the same thing, giving very fast response and efficiency that ties right into this whole picture of both comfort in terms of response time and efficiency, which is all part of modern heating philosophy.
Very cool. And would you mind diving into the hydronic side? Like, what does hydronics mean? What kind of energy source do you typically use for these radiant floors? For the people who have maybe only had a traditional forced air heating system in the past.
Sure. Most people are familiar with FAU, forced air unit, that blows air over them when they want heat. It's cold air on them when they want to cool down. Those systems primarily heat air, and they circulate air. Radiant systems heat objects. So you have a warm object like a floor, it re-radiates out to cold surfaces.
Gotcha.
A smaller percentage actually heats the air. And that has multiple benefits. And the number one is anybody who's been in a radiant floor heating house, the number one thing, that's the most comfortable thing I've been around. And maybe we can discuss more about why that is the case and why people go that direction, taking warm water from a water heater or a boiler or air-to-water heat pump, warm water, putting it through the floor, warming it to meet the load and generate the comfort in the space.
Okay, gotcha. Very cool. And now, David, I was curious as to how this impacts a project score for, the Active House certification. And maybe before that, you want to describe how Active House evaluates these buildings?
Sure. So Active House has 9 points of concentration. Comfort is the main one. The idea is that they want to make sure when you build a house or you finish remodeling your house, it is absolutely as comfortable as humanly possible. In comfort, it looks at what humans like, what their senses sense. What they can see, what they feel, their touch, what they smell, indoor air quality, and what they hear, acoustics. I mean, that's what, humans want in terms of daylight, lots of volume, lots of glass. It's just what humans like.
Of course.
Try as they might, we want to make an efficient building, but we also want to design what humans want to be in. In terms of comfort, what radiant floor heating does is by raising the floor temperature and radiating to the ceiling and to the walls and to the windows, your skin will radiate heat away from it much slower. You just feel more comfortable. The true human comfort in terms of it's a combination of temperature and then the surroundings and then your surrounding objects. And so radiant gives you a great chance of really feeling comfortable. As Morgan mentioned, once you go radiant, there's just no going back. I mean, it's just like driving a really, really nice car. Yeah, sure, there are other ways to get from A to B, but, radiant is just fantastic. The other thing about radiant It touches on at least 4 other objects or 4 other items in the active house radar. Acoustics. Radiant's silent. It's not quiet, it's silent.
No noise.
You don't hear a thing. And so true human comfort is hearing what you want to hear and not hearing what you don't want to hear.
Of course.
Radiant gives you that. What's great about Radiant, back to daylighting is, especially with modern architecture, humans like lots of windows, nice big open spaces, skylights, volume. And the only way to make those, but trying to blow warm air in those spaces, you don't have a comfortable space. But heating the floor properly to the right temperature will really, really make it comfortable. The other things that impact comfort, zonability. For what's comfortable in your space, you may have one of your family members that wants it either much warmer, much cooler. Radiant gives you room-by-room control, and you don't pay an extra nickel for it. And then the other thing that the other things that Radiant touches on is on your energy supply topic within, Radiant's very, very efficient. It allows the use for air-to-water heat pumps, which are also efficient in converting the electricity to warm water very efficiently. And of course, that electricity can be provided by solar, so it ties into that. And lastly, and Morgan can explain this more, is Active House is very focused on sustainable construction, and Morgan's rice panel, I think that's how we say it.
Rice straw.
Rice straw
Oh, wow. Can we see
is
that?
one of the ways that Morgan is delivering the radiant heating is through quite a unique product. You want to talk about
Sure.
Let's jump into
Maybe
the
I'll just do a
products.
quick overview. We actually, over the years, have come to manufacture 3 types of aluminum-clad lightweight panels to go over subfloors of concrete. One of them uses plywood because a lot of contractors just prefer that as going over a subfloor as a subfloor material. Another one we've introduced, we came upon this amazing company in the Central Valley of California in the middle of the rice fields. You didn't know
wow.
most of the rice actually comes from California.
I did not know that.
And huge area. And they've had multiple problems. They used to burn off the rice straw every fall, huge, cover the valley with smoke until, air quality said, you're not doing that anymore. Then they started flooding the fields. But the problem is when they drained them, there was all sorts of methane coming off them from rotting.
Okay.
So people said, maybe we have a different way to do this. So what they have built this $850 million plant in the middle of the Central Valley, where they make a very high quality MDF, medium density fiberboard, but it's made of rice straw.
Wow.
The raw materials are just about free. They're trying to get rid of them. They're right there.
Yeah, exactly.
There's no transportation costs. There's no burning off. You don't have
You're
to chop
preventing
down
all
trees.
that.
You
Wow.
don't have to run trucks around. It's really as closer to God in terms of sustainability. That's for sure. And we just found that more and more architects, builders are interested in sustainable components. Yeah. And that's where this product, thermal board, sustainable radiant panels, come into play. We also have a product called Insul Heat we've introduced to go over concrete. Thermal board, radiant board, they go over raised subfloor.
Got it.
Insul Heat goes over concrete. So the insulation is right there. Instead of pouring concrete, as you would in the old-fashioned slab, everybody thinks of radiant heating. They think of big, thick slabs, tubing inside, and poor response time, and all those things.
Super slow response time.
This product goes over the slab, so it gives immediate response, much more efficiency than the alternatives. And while it is foam, EPS foam is fully recyclable and has much better credentials from a green perspective than other foams in the marketplace. So that's my quick
Very
overview.
cool. And I see you have 2 options for this Insul Heat.
Well, we have the standard is 1 inch thick R5, and then we have an R10, 2 inch. But we're also just looking at making custom sizes thicker for engineers who. There are reasons if you're in North Dakota why you might want thicker insulation than you would in California.
Yeah, let me jump in just for a second. So the engineering company I work for, we've designed just under 9,000 radiant floor heating systems in the last 30 years since people started to use radiant floor heating again. If we've learned anything, is that you want the radiant system to heat up quickly and cool down quickly. And there's a bunch of different ways of putting radiant floor heating in. Morgan mentioned putting it in a concrete slab, which can take several hours to heat up. Customers aren't happy then. You can go underneath the subfloor as a way of delivering the heat. And it doesn't, there's a couple problems with that. Sometimes it's the only way to go if it's in a retrofit and you're trying to keep your hardwood floors. But in new construction, it really is not the best way to go. It takes longer to heat up. You need much hotter water. And what that does, it just basically eliminates the possibility of using an air-to-water heat pump as the heat source. You have to use a high-temperature gas boiler. Well, that's fine unless you happen to be in one of the states that have outlawed that. And we're in California, and we're one of those states that as of January 1st, you could no longer use a gas boiler for any new construction project.
And New York is chasing them in those sort of requirements.
Exactly. So when we use these air-to-water heat pumps, they're nice, they're very, very efficient, but they only supply about 120-degree water when it gets cold outside, sometimes even a little bit less. And so we have to go on top of the subfloor, and we really want to be in a thin aluminum surface like this, so it'll heat up quickly.
Low thermal mass.
Low thermal mass is the key.
Okay. Now that you've mentioned this whole temperature difference, Morgan, like what temperature water do you tend to look at for heating for a system like this?
Just generally speaking, the lower the better.
Okay, is that
the higher the temperature you use, the less efficient it is.
Got it. You're trying to keep it
that's
low.
an engineering maxim.
Yeah.
So when we can have a thin mass, highly conductive type of product, we can use lower supply water temperatures, which means inherently more efficient. That's where the efficiency comes. So yes, if we could be 120 degrees and below, absolutely. I mean, as Dave will talk about, the heat loss requirements have just plummeted in new construction in the last 30 years. So it's right up our alley because low temperature can be used.
What determines what water temperature we're supplying is the heat loss of the space, and also the R value of the floor covering above it. So we can have a nice efficient space. If we've got shag carpet, we would need, or just even nice thick carpet, we would need pretty high, supply water temperatures. If it's all tile or a thin engineered floor, we would be much less.
Got it.
But it does make a big difference because the efficiency of the air to water heat pump, the hotter the water we have to create, the less efficient it is.
Okay.
And the more solar we would then have to produce to kind of even it all out.
Got it.
So in the end, it's up to the architect to design the space. It's up to the owners to pick their floor coverings. We can work with almost within any part of it. It just does impact the design and the efficiency. So.
Okay, and then so Active House in the evaluation takes all these factors into account?
Absolutely, and again, the lower the heat loss, you get a better score in your energy demand, and then in your energy supply, which is the solar component, the more efficient the house, the less solar we need to zero out their energy use.
Makes sense.
There's one more factor that's come into play a lot recently, which is being able to, the rules have changed in California in terms of the net metering, in terms of solar production. So the idea of being able to use the energy we're producing on site, and the way we can do that with floor heating is great. We can just basically go from the roof to the air to water heat pump to the floor. If there's a delay, we can store it either thermally with some hot water tanks. We're starting to look at using phase change eutectic salts as a way of storing the energy, so we can produce on site and consume on site, and that's the goal.
Very cool. You want to real quick just touch on what that phase change, whatever you call it, is there any information you can provide? Just, something really simple, not too engineering oriented. So, but how it'll help the system.
Right. So, well, some ways it's easier to think of it in terms of, there are materials that will absorb energy, and they'll absorb energy to the point where they're not quite ready to change phase, and they can absorb a tremendous amount of energy. And then when they change phase back, they'll be able to give off that energy. And there's different salts. It's the sort of thing that's been out there for years, but it's never really been a demand for it.
Okay.
The demand is starting to happen. As everybody knows, renewable energy is great as long as you can store the energy. Yes. Whether it's batteries, phase change, hydrogen, there's a lot of options. The next 5 years are going to be fascinating to see what plays out.
Very cool. And that kind of leads to the next thing, the hydronics industry in general. Have you seen a nice increase in demand over the last 5 years? What direction do you guys think it's headed? Both of you have been in this industry for quite a while. You've seen how things have developed.
I would say it's probably flat, to tell you the truth. What's going on with the industry now for a variety of different reasons. We'd like to see, obviously the radiant industry has been the growth element of the
Okay.
hydronic industry. The hydronic industry, when you talk about it, I don't
It's
know,
very
for
broad,
people
yes.
back east will remember the baseboards and the old radiators and all that. That's also hot water going through, but it's much higher temperature, less comfortable way to go about it.
Less
But
efficient
the
as well.
radiant heating has been the driving force behind the hydronics industry. Hydronic industry is facing a big challenge, as Dave's been discussing. They've used boilers. Well, heat pumps are going to be the future, and that's why you're seeing all sorts of players, Space Pack, but even LG. All these major players are coming in with air to water because it's dominating now in Europe. And
Oh, yes.
it's trickling over. The prices are a little high for them right now, but they're coming down.
Okay. And is there any type of like government rebates or anything like that you're seeing, Dave?
Well, there certainly is in geo, which
Okay.
is one way to produce the warm. There's an alternative to using an air to water heat pump. It's using a geo exchange heat pump. The tax credits for that just quadrupled in the last year.
It's variable by state. For instance, in Massachusetts, where I live half the year, they give $10,000 for an air to water heat pump change out from a boiler. So and New York is pondering all sorts of major rebate programs, not to mention these billions of dollars floating around now for heat pump conversions. It's a big subject out there right now.
Yeah, I think hydronic heating, I mean, to me, the big indicator is in the last 6 months, LG and Mitsubishi have brought on,
Yes.
hydronic systems.
I was at AHR in Atlanta recently, which is the HVAC trade show. And LG finally brought their air to water heat pump that hadn't been seen there before. And so these companies are starting to bring them. It's great, very popular in Europe, but now they're coming to the US.
Yeah, and one of the main reasons is they don't need to. It's a way to future proof. I mean, when we actually in our office yesterday, we had LG introducing their air to water heat pump, as well as their heat pump water heater and some other, and their big battery system, and they're making a huge push in the battery world. But they were talking about future proofing, and one of the ways you future proof is if you go hydronic, because you don't have to worry about changing out equipment based on refrigeration, the refrigerant changes that may be coming. So there's a real advantage there. You get a lot of flexibility with hydronic heating and cooling. You save space. And when you save space in a house, you save money. Aesthetics are another one. Radiant floor heating is invisible. Radiant ceiling space conditioning, invisible. Guess what? Architects love that.
Yeah.
When you save space, you save money. I mean, if you're spending $500 to $1,000 a square foot in a custom home, and you can save them, I don't know how many square feet by not having to build chases and big mechanical equipment spaces, things like that, you can save the cost of the system. So there's a lot of advantages of going hydronic. One of the big disadvantages is the subcontractors tend to charge a lot more in the hydronic world than they do in the forced air world. There's much less competition. There's much less training, kind of tragically. So it's a slow adoption. But it should turn around.
As it goes.
Should turn around.
Yeah, that's really dependent on the locale. Some area will have several good contractors vying for business, and then other areas just won't have that competition. So,
but you can see when the big companies are starting to get serious about hydronic heating and cooling, then you're on the right track. I mean, our engineering company, we're agnostic. We'll go either way. Sometimes the codes determine it. Right now in California, the energy code is just madly in love with ductless mini splits. I mean, to an incredible degree.
Yes.
It's funny to talk to people like LG or Mitsubishi or Samsung, and they go, "Yeah, we kind of created a monster there. Now we're trying to go to hydronic, and yet there's this huge delta, but it'll get evened out. In the end, the best systems will win, and one of the absolute best systems, and you can't talk people out of it, is putting radiant floor heating in, because there's just so many advantages.
Very cool.
Yeah, the big challenge for the radiant floor heating world is how are we going to cool the space?
Yeah.
I mean, it's, and especially in modern architecture, I mean, even if you're on the coast or one of the coasts, or even in a cold climate like Seattle, you put enough south and west facing glass in a house, it gets hot.
Oh yeah.
And so, being able to cool the space is critical, and we have about 3 good options. One is you can use radiant floor cooling.
Really? Okay.
If and only if you have like a tile or exposed concrete or some sort of stone, surface. And even then, it's maybe not the best choice, because walking on a cold surface, even when it's hot, isn't super comfortable. And you're limited to maybe 10 BTUs a square foot, a little bit more if the sun is being absorbed directly, it's a little bit more. But if you're away from being able to absorb the sun, it's it's just not the world's best way to cool a house. The radiant ceilings, which do give you heating and cooling, and the cooling is phenomenally comfortable, so that's a great option. And the last thing is we often match our radiant floor designs with just a hydronic fan convector, which is just a device that's got a heat exchanger and a fan behind it. We run chilled water through that. They're usually flush mounted either in the floor, wall, or ceiling, so they look great. Really? They don't take up any space, and they're using the same mechanical equipment that you're using to produce the warm water to do the radiant floor heating. That same equipment can also do the domestic hot water, which is a big difference from your refrigerant-based systems because they can't touch that. And then more recently, and so anyway, so you get that 3-in-1. You're doing your heating, you're doing your cooling, you're doing your domestic hot water, all off of one compressor that sits outside.
Wow,
so that's a nice way to go.
Okay, and I know if you were to use chilled water, there's potentially concern about, the dew point. How is that avoided? How do you deal with that?
Well, we're in Central California where we don't really worry about it all that much, but just because we tend, when we're hot, we're dry. But for the rest of the country, and we work all over the country, is you do have to supply, dry air. And the great thing is, one of the Active House sponsors, Masana, has fantastic controls that not only control the radiant heating, it controls the cooling, and it controls, when and how much dry air to introduce to the space.
So not an issue there. No worries.
There's a way. Yeah, I mean, it is an issue. You just gotta.
Well, yes, but with a system like that.
And I'll do a little boost there for Masana too, because there haven't been very good control systems for doing radiant cooling. It's been a bit of a control monster. And Masana's really come together with one box that can do everything you need to do, which is really making radiant ceiling cooling much more attractive or in the floor than it used to be, even a few years ago. Yeah.
Very cool. That's some cool technology. I did want to ask something specific to your panels that might differentiate you a little bit. I kind of read through your website and I noticed that you guys have some interesting patents. One of them was the overbite design. Do you want to kind of touch on that and how maybe it helps your system?
Well, what it does is that maybe this is a little hard for a non-visual relationship here, but when there's a groove put in our panels, and then we snap the PEX tubing into them. When you have overbite, you have greater contact. Like if you have it just straight U-shaped, you get about 50%. With ours, you get about 64%.
Okay.
So in other words, when you're designing a heat exchanger, the more surface connection between the heater and the plate you're trying to heat, the more effective it is as a heat exchanger device.
Got it. Okay. So it increases performance.
Yeah, that's just one of the things we do to achieve better performance. Other people do it different ways. So,
very cool.
Yeah.
Awesome. Any other?
I just kind of want to sum up by saying, we were attracted to the Active House building philosophy because it really spoke to us. It really, we work for about 250 architectural firms. I had a great sense of what architects and builders are looking for in the custom home world. And Active House really spoke to us. With radiant floor heating, so there's nine items that Active House looks at in terms of trying to provide true human comfort, sustainable construction, and overall energy efficiency. Radiant floor heating touches on 6 of the 9.
Wow.
I mean, so it's not only, it's human comfort, the mean radiant temperature, and really being, just thermally comfortable in the space. It allows for much greater amount of daylighting because you can achieve that comfort even in a room with a lot of glass, a lot of volume. Acoustics, again, it's silent. Energy demand, radiant floor heating is amazingly efficient to heat the space because it's not, it's not overheating. You get great zonability. There's lots of efficiency ties in there. So in terms of energy demand, in terms of energy supply, going from our solar electric to air to water heat pumps to do our domestic hot water, our space heating and cooling, it's all right there. And then again, lastly, with sustainable construction and the very creative WBI rice straw panel. Yeah, close enough. So anyway, it's really kind of it's a great match.
So a product like this definitely heavily affects the Active House project score on the Active House radar.
Oh yeah, and one other thing is, to go through the Active House evaluation radar, it's very time efficient. It's very low cost. It's really fun, and it's something we encourage architects to look at for their next projects because I think they can they can help quantify to their clients,
Show them.
to show them, yeah, hey, look, we're taking that extra step to make sure the house is truly special.
Cool. And how does the certification work? Is there a certain threshold you're aiming for for the radar score?
Right. So as you mentioned, it's kind of like golf, the lower the score, the better. And so we want to average on a scale of 1 to 5. In order to be certified, I think we have to be below 2.5 or something in that range.
Okay.
And then, but the evaluation, I mean, even if you don't quite make the certification stage, the evaluation is still really valuable. And again, it's such a time efficient, low cost endeavor. We were just giving all through February, every project we had, we just said, okay, we'll give you a free active house evaluation just to kind of see what was going on. And I think our clients really, really enjoyed it. So
very cool. Hopefully we see more of those evaluations taking place. We can add some projects to our website. Very cool. Morgan, before we finish up, is there a way people should look into WBI? Is there a website you want to reference?
The easy way, we're at warnbrothersinc.com.
Okay.
You go there, you can see the different products, our history. We have a great deal of data built up over the years relating to all 3 products. You can click through. And the easy thing is you can just give us a call. Got a project, have something in mind, give us a call or give us an email. There are a bunch of people waiting around that are project managers. And what we do is we actually sell factory direct all over North America to contractors. So we take the project right through the layout, the design, the shipping it directly to the job site. So we're vertically integrated to that extent to get great results each time.
Great. And so actually one last question on that, on installation. For the people that might be listening, interested in doing it themselves, is this a product that they can do that with for their own home?
They can. Again, we sell by the project, so they submit plans, and then we provide a quote within 24 hours, and they then can go to get a layout. We don't just sell it out like an online outfit and hope things work out. But yes.
Very cool. Okay, so DIY friendly.
Great.
Indeed. And then Dave, do you want to talk about, is there anything else you'd like to add?
I would say that, like I mentioned, we're just about at 9,000 radiant hydronic systems designed. A lot of those are for do-it-yourselfers. I would say it kind of stops at the floor. Laying down the boards and the tubing, it's pretty easy. Almost if you were trying to save a couple bucks, it's easily done. At the mechanical room, it gets a little more complicated. And then now with air to water heat pumps, it's a whole nother level. And it's also something that, the radiant business has been 99% heating since, it started to emerge in the mid 80s. That's all changing. Okay. And it's changing because of just the design of homes. It's changing because the demands of our clients, and it's changing because of codes. Codes are now requiring use of air to water heat pumps. They produce warm water. They also produce chilled water. So what are we going to do with that chilled water? Well, we're going to provide cooling. And so that's become, and again, the hydronic heating contractors, they've never done cooling before. You mentioned dehumidification and all that. So it just takes a little extra thought to get it done right.
Very cool. Okay, well, I want to thank you gentlemen for being here. It's been a great show, great conversation. For anyone interested in learning more about Active House, our website is activehouseusa.org. We are also active on social media at Active House USA. Thank you everyone for listening. Take care.